December 3, 1945, Sugamo Prison, Tokyo. Admiral Chuichi sat at his desk, pen in hand, methodically recording observations that, only months earlier, could have cost him his life. Once the commander of Cruiser Division 5 and a seasoned veteran of 7 significant naval engagements, he was now compelled to confront the harsh reality of Japan's defeat, a reality he had glimpsed long before in the aftermath of the Philippine Sea Battle. He noted with grim precision that American forces were replenishing their losses at a rate that far outpaced Japan's ability to claim victories. "We were essentially battling the sea itself," he reflected. "No matter how many ships we sank, more would always come." Beyond the prison walls, the remnants of Tokyo extended as far as the eye could see. The city, once the heart of the Japanese Empire, had been transformed into a desolate landscape of ruins flattened by waves of B-29 bombers operating in numbers that had overwhelmed Japanese defenses. In the nearby harbor, massive U.S. warships, far larger than anything Japan had previously imagined, lay at anchor. Their crews moved with routine efficiency, maintaining instruments of war representing more steel than entire Japanese municipalities had ever contained. Inside Sugamo's interrogation chambers, Japan's senior naval officers faced a reality they had long resisted acknowledging, either through denial or decree. Confronted with incontrovertible evidence, they were forced to admit that Japan had engaged an industrial superpower that outproduced them not marginally, but exponentially. The testimonies they provided to the U.S. Strategic Bombing Survey would not only illustrate Japan's military defeat, but also expose the impossibility of matching American industrial output, a candid acknowledgement rarely seen in the annals of wartime documentation. These officers detailed with care how their nation had embarked on conflict against an adversary capable of producing in a single month more aircraft than Japan could manufacture in a year. The roots of this miscalculation stretched back decades. Admiral Yamamoto, who would later orchestrate the attack on Pearl Harbor, had first-hand knowledge of America's industrial might. Between 1919 and 1921, he studied at Harvard and subsequently served as a naval attaché in Washington. Returning to Japan, he issued warnings that largely went unheeded. In correspondence from January 1941 to Navy Minister Koshiro Oyawa, Yamamoto emphasized the futility of a naval arms race with the United States, citing the scale of Detroit's automotive plants and Texas's oil production. His assessment proved to be remarkably prescient. Captain Minoru Genda, another architect of Pearl Harbor, had first-hand exposure to U.S. manufacturing efficiency in 1940. On a military mission, he toured Boeing's Seattle factory, where B-17 bombers moved steadily off assembly lines. The plant's mass production methods dwarfed Japanese capabilities. While American factories could complete a heavy bomber in days, Mitsubishi required 3 weeks to produce a twin-engine aircraft. In the same period, a Mitsubishi delegation visiting Douglas Aircraft in California observed 6,000 workers on a single shift producing DC-30 transports, later adapted into C-47 military cargo planes, an output that underscored the stark disparity between Japanese and American industrial capacities. These records, preserved in meticulous detail, captured the scale of Japan's misjudgment and the enormity of the industrial challenge it had attempted to confront. They revealed not merely strategic and tactical failures, but the fundamental impossibility of sustaining a war against a nation whose production capabilities operated on an entirely different magnitude. In 1941, the entire Japanese aircraft manufacturing sector employed roughly 35,000 individuals across all companies. Remarkably, a single American factory alone accounted for nearly 1/5 of that total workforce. Despite these stark figures, Japan's top military planners largely dismissed the potential threat. Admiral Osamu Nagano, head of the Naval General Staff, conveyed to Emperor Hirohito in September of that year that American laborers lacked discipline and resilience, producing machines in large numbers but with insufficient quality. He expressed confidence that Japan's rigorous training and fighting spirit would more than compensate for any material shortfall. Post-war examinations revealed that Japan had accurate intelligence on American industrial output, data collected by the Navy Ministry itself, but this evidence was largely ignored. The disparity was enormous. In 1941, the United States was producing 19.4 million tons of steel annually, while Japan managed only 5.8 million tons. U.S. daily oil refining reached 4.3 million barrels, whereas Japan could access a mere 55,000 barrels per day, most of it from occupied territories. December 7, 1941, brought the attack on Pearl Harbor, a tactical operation that initially seemed a resounding success for Japan. 8 battleships were sunk or damaged, nearly 190 aircraft destroyed, and over 2,400 American personnel killed. On the surface, it appeared that Japan had incapacitated the United States Pacific naval strength in just 1.5 hours. Yet, Admiral Chuichi Nagumo, commanding the attack fleet, recognized the deeper implications almost immediately. In post-war questioning, he admitted his concerns. No aircraft carriers had been caught in the strike. Oil storage facilities remained intact, submarine bases were untouched, and repair yards were fully operational. Lieutenant Commander Minoru Genda, flying over Pearl Harbor as an observer, later described to American interrogators the scale of the support vessels present. He noted that auxiliary ships, tenders, oilers, and cargo vessels vastly outnumbered the Japanese battle fleet, underscoring that Pearl Harbor was not the heart of American naval power, but just one node among many. Other bases, San Diego, Bremerton, Mare Island, Hunters Point, individually equaled or exceeded the capabilities of Japan's main naval yard at Yokosuka. The Battle of the Coral Sea in May 1942 revealed the resilience of American industry in stark detail. When the USS Yorktown sustained heavy damage from Japanese bombs, intelligence estimates predicted repairs would take 3 to 6 months. Yet, once in Pearl Harbor dry dock on May 27, 1,400 workers were mobilized immediately. Temporary power plants supplied electricity, pre-cut steel plates were ready, and welding operations blazed continuously. Within 72 hours, the Yorktown was fully operational and sailed to join the Midway engagement on May 30th. In contrast, Japan's carrier Shokaku, damaged at Coral Sea, required 11 weeks of repairs at Yokosuka. Post-war studies highlighted why this gap existed. American shipyards utilized pneumatic tools, electric welders, and an abundant supply of steel, whereas Japanese yards depended on hand labor and makeshift materials. By June 4, 1942, at the Battle of Midway, the numeric and industrial realities became undeniable. Japan lost 4 aircraft carriers, vessels that could not be replaced in time, while the United States, bolstered by its vast industrial capacity, remained able to sustain and even accelerate its war effort. The attack on Pearl Harbor, once celebrated as a triumph, now revealed itself as a tactical victory overshadowed by a strategic defeat that Japan's leaders had failed to fully anticipate. The Battle of Midway marked a turning point not simply because of the carriers lost by Japan, Akagi, Kaga, Soryu, and Hiryu, but because it exposed the stark difference in the two nations' industrial resilience. Admiral Matagaki, serving as Chief of Staff to Admiral Yamamoto, noted in his diary on June 10 that while the United States could replenish its naval losses within a single year, Japan lacked the capacity to do so for a decade. Even this assessment underestimated American capabilities. By the end of 1942, the United States had already commissioned the first of its Essex-class carriers, a fleet that would eventually grow to 17 ships alongside 9 Independence-class light carriers. In contrast, Japan managed to complete only 3 additional fleet carriers throughout the entire conflict. The gap in naval aviation was just as consequential.
At Midway, Japan suffered the destruction of 248 aircraft and the loss of 110 highly experienced pilots, airmen whose skills could not be quickly replaced. The Americans lost 150 planes and 60 crew members, yet within 6 weeks, their carrier air groups were restored to full operational capacity, equipped with both newly manufactured aircraft and trained personnel. Japan, however, never regained the strength it had held before Midway. Meanwhile, the campaign along the Guadalcanal coastline from August 1942 to February 1943 highlighted the decisive role of logistics in modern warfare. Over the course of this campaign, the two sides clashed in 7 major naval engagements, with ship losses appearing superficially similar. The United States lost 29 vessels, while Japan lost 38. The reality, however, lay in the aftermath. Interrogations of captured Japanese personnel and U.S. assessments revealed that within 6 months of the campaign's conclusion, the United States had rebuilt its naval strength to exceed the total number of ships it had lost. Japan, by contrast, struggled even to replace its destroyers. The Tokyo Express, Japan's nighttime destroyer runs to resupply forces on Guadalcanal, illustrated the logistical imbalance in stark terms. Each destroyer, consuming valuable fuel and risking enemy attack, could deliver roughly 240 tons of supplies per mission. Meanwhile, American Liberty ships, produced on assembly lines at the astonishing rate of 3 per day, could transport 10,000 tons of materials in a single voyage. In other words, a single U.S. cargo ship could move as much as 40 Japanese destroyer runs combined. The consequences on the battlefield were severe. Japanese troops on Guadalcanal suffered from chronic malnutrition and were operating at only about 30% combat efficiency by December 1942. American forces, conversely, reported complaints not of starvation, but of boredom with their meals, consuming approximately 4,700 calories each day.
The numerical contrast in production and supply capacity between the two nations was staggering. Where Japan relied on a handful of vulnerable, fuel-hungry ships for resupply, the United States leveraged its industrial output to sustain a scale of warfighting that Japan simply could not match. These disparities in shipbuilding, aircraft production, and logistical throughput would shape the trajectory of the Pacific War far more decisively than any single engagement. By the beginning of 1943, Japanese naval intelligence had acquired a remarkably clear picture of American wartime output. The figures were so shocking that they were designated above top secret. Captured documents from the post-war period revealed the scale of production during March 1943. The United States was manufacturing 7,200 aircraft monthly, while Japan managed only 650. Engine production showed an even starker contrast, with 18,000 engines coming off American assembly lines compared to Japan's 1,200. Pilot training followed the same pattern. The U.S. trained 12,000 aviators each month, whereas Japan could only graduate 300. In terms of naval construction, the U.S. launched 48 warships to Japan's 3, merchant vessels numbered 140 against 8, and submarines tallied 8 versus 2. Rear Admiral Sakichi Takagi, reviewing these statistics with the Naval General Staff, reportedly remarked to his peers, "If even half of these numbers are accurate, our defeat is already sealed." His concern was justified. The numbers actually understated American output. Production in the United States was growing at a pace that Japan could scarcely comprehend. The Willow Run factory alone churned out 650 B-24 bombers every month, while Japan's total heavy bomber production for the entire war amounted to just 15 planes. This massive industrial advantage became starkly evident during the Battle of the Philippine Sea in mid-June 1944, often referred to as the Marianas Turkey Shoot. Japan managed to assemble 9 aircraft carriers with 473 planes, but the U.S. countered with 15 carriers fielding 956 aircraft. Vice Admiral Jisaburo Ozawa, commander of the Japanese fleet, later testified during U.S. investigations. Japanese pilots averaged less than 200 flight hours of training, whereas American aviators had a minimum of 600 hours. Japan's fuel shortages restricted practice, while U.S. pilots trained relentlessly. The technological gap was equally decisive. American carriers deployed F-6F Hellcats equipped with 2,000 horsepower engines, .50 caliber machine guns, self-sealing fuel tanks, and armored plating. Japanese Zeros, essentially unchanged since 1940, lacked armor and self-sealing tanks and relied on engines with only 950 horsepower. The outcome was devastatingly predictable. Japan lost 476 aircraft and 3 carriers, along with 480 aircrew and 8 months' worth of pilot training output. The U.S., by contrast, lost 130 aircraft and no ships, and replaced lost personnel in days, thanks to a training program producing 3,000 naval aviators per month. The introduction of the B-29 Super Fortress in late 1944 further underscored America's unmatched industrial and technological capacity. The first raids over Tokyo, launched from Saipan, featured bombers costing $639,000 each, more than the construction cost of many Japanese government buildings. A total of 3,970 B-29s were built, with the program consuming $3 billion, surpassing Japan's entire annual military budget. Each bomber contained 55,000 meticulously engineered parts, featuring pressurized cabins, remotely operated gun turrets, and precision bombing computers, technologies Japan could not hope to replicate even with 10 years of development. The B-29 campaigns exposed the full extent of America's industrial might, demonstrating a scale of production, technological sophistication, and logistical organization that was far beyond Japan's capacity to challenge. The disparity between the two nations had become a decisive factor, foreshadowing Japan's inability to recover from successive losses in men, machines, and material. During World War II, American bombers conducted long-range raids that showcased the sheer scale of U.S. industrial and logistical capabilities. One operation involved aircraft traveling roughly 1,500 miles to reach targets in Japan, releasing their payloads, and then returning to base. Each plane covered a 3,000-mile round trip, consuming approximately 6,000 gallons of aviation fuel. In a single 500-aircraft raid, total fuel usage reached 3 million gallons, equivalent to Japan's entire monthly aviation fuel production. The infamous Tokyo raid of March 9th to 10th, 1945, saw 1,665 tons of incendiary bombs dropped, leveling roughly 16 square miles of the city. The quantity of ordnance deployed in this single mission exceeded Japan's entire stockpile of aerial bombs at the time. The invasion of Okinawa in April 1945 further highlighted the imbalance between Japanese military resources and American industrial output. The U.S. assembled a fleet of 1,457 vessels for the assault, surpassing the total number of ships the Imperial Japanese Navy had ever maintained. Vice Admiral Takeru Onishi, the architect of Japan's kamikaze program, acknowledged the limitations imposed by this disparity in his final testimony before taking his own life. Reflecting on the battle, he remarked that just the screening force alone contained over 100 destroyers, whereas the entire Japanese Navy retained only 11 operational destroyers. The kamikaze campaign at Okinawa illustrated the limits of bravery in the face of overwhelming industrial power. Japan launched approximately 1,900 kamikaze attacks, sinking 36 American ships and inflicting damage on 368 more. Yet, within 2 months, every sunken vessel had been replaced, and the majority of damaged ships were restored to operational status. American supply operations during the campaign were equally astonishing. Each day, transport ships delivered 50,000 tons of essential materials, including food, ammunition, fuel, and medical supplies, to the front lines.
Japanese logistics could not hope to match this pace. Their merchant fleet was incapable of moving even 50,000 tons per week for all their forces combined. Submarine warfare exemplified the strategic impact of industrial and technological superiority. While Japanese crews made up only 2% of the global submarine personnel, they suffered catastrophic losses in terms of tonnage. Between 1944 and 1945, American submarines systematically targeted and destroyed Japanese merchant shipping. The United States commissioned 228 submarines, all produced on assembly lines, while Japan constructed 126 boats individually by hand. By January 1945, U.S. submarines had eliminated 60% of Japan's merchant fleet, totaling 4.8 million tons. In contrast, Japan's shipbuilding industry could only manage around 500,000 tons annually, whereas America's Liberty ship program alone produced the same tonnage every month. The disparity extended beyond numbers to technological and human factors. American submarines offered air conditioning, cold food storage, ice cream machines, and basic hygiene facilities. Japanese crews endured extreme conditions, often operating in 120-degree heat with minimal nourishment, subsisting largely on rice and pickled vegetables, which led to widespread scurvy and beriberi. By August 1945, Emperor Hirohito's announcement of Japan's surrender marked the end of hostilities, but post-war interrogations revealed the staggering scale of industrial imbalance. Japanese officers, speaking freely for the first time under Allied oversight, provided detailed accounts to the U.S. Strategic Bombing Survey. Admiral Ciemu Toyoda, the final commander of the combined fleet, offered testimony in November 1945, confirming the overwhelming magnitude of American production capabilities that had decisively shaped the war's outcome. Before the outbreak of the Pacific War, the United States possessed an abundance of raw materials, extensive natural resources, and an industrial capacity capable of mass production on a scale unmatched by any other nation. In comparison, Japan's steel production was limited to roughly 6 million tons per year, whereas the United States generated between 80 and 100 million tons annually. This vast disparity was reflected across nearly every category of military hardware. During the conflict, the U.S. outproduced Japan by enormous margins. The United States manufactured approximately 325,000 military aircraft, while Japan produced just over 76,000. Tank production showed an even starker contrast. The U.S. built over 88,000 units, whereas Japan assembled only 2,500. Similarly, military trucks numbered over 2.3 million in America compared to fewer than 166,000 in Japan. Aircraft carriers were another area of overwhelming imbalance, with the United States commissioning 141 while Japan fielded only 17. Battleships, cruisers, destroyers, and submarines all followed the same pattern of American superiority, underscoring the industrial gulf between the two nations. Admiral Isoroku Yamamoto, Japan's leading naval strategist, had anticipated the scale of this disparity well before hostilities began. Though he was killed in April 1943 during a targeted mission carried out by American P-38 fighters, an operation enabled by the breaking of Japanese naval codes, his pre-war analyses, preserved in naval archives, proved uncannily accurate. In a September 1941 letter to Navy Minister Osawa, Yamamoto warned that if Japan went to war with the United States, the capture of Guam, the Philippines, Hawaii, or even parts of the U.S. mainland would not suffice. He cautioned that only a march to Washington and direct control over peace negotiations could theoretically secure Japan's aims, while expressing doubt over whether Japanese political leaders were prepared for the sacrifices that would entail. Yamamoto's most striking forecast appeared in correspondence with Admiral Inoue Shigeyoshi, in which he predicted that Japan could achieve rapid and spectacular victories during the initial 6 months to a year of conflict against the US and Britain, but that success beyond that period would be virtually impossible. His assessment reflected a deep understanding of the underlying industrial and technological limitations confronting Japan. This recognition was shared by Japanese technical officers and engineers, whose testimony during post-war interrogations provided detailed evidence of America's overwhelming industrial advantage. U.S. shipbuilders, for example, were 5 years ahead of their Japanese counterparts in welding technology. Entire sections of ships were fabricated in factories and later assembled like modular components, while Japanese shipyards still relied on the labor-intensive method of riveting plates individually. A single American worker could accomplish the output of 10 Japanese laborers, and the overall quality of construction was superior. Examination of captured American equipment further highlighted this gap. Parts were manufactured to exact specifications and designed for interchangeability, whereas Japanese designs required painstaking hand-fitting. In practice, the United States was able to mass-produce equipment of higher quality than Japan could achieve even through custom craftsmanship.
These differences became even more apparent during the post-war occupation. By August 30, 1945, the systematic study of Japan's defeat revealed that technological expertise, industrial scale, and methodical mass production had decisively shaped the outcome of the war, validating the warnings and predictions made by Japan's own military leaders before the conflict had begun. When General Douglas MacArthur arrived at Atsugi Airfield, he marked the beginning of the Allied occupation of Japan. During the first few weeks, Japanese military leaders were confronted with stark evidence of the United States' overwhelming industrial capacity. The fleet stationed in Tokyo Bay alone included hundreds of warships, more than the entire Japanese Navy had ever possessed in its history. Importantly, this represented only a portion of the U.S. fleet, chosen for logistical convenience rather than necessity. Within a matter of weeks, American personnel had taken control of Japan's communications and transportation systems, including telephone lines, postal networks, radio stations, and railway operations. These systems functioned with a level of efficiency and reliability far surpassing anything Japan had managed to build in decades. The Americans not only restored infrastructure damaged during the war, but did so faster than Japan had ever completed original construction projects. The scale of American food aid further underscored the imbalance between the two nations. Through coordinated relief efforts, the U.S. government provided approximately $1.7 billion in support to the occupied country. Nearly 60% of this aid, around $1.19 billion, consisted of food and agricultural supplies. A single Liberty ship could transport 10,000 tons of wheat, sufficient to sustain an entire Japanese city for months. Hundreds of such ships arrived in succession, supplying food to Japan on a nationwide scale, all while the American population experienced no shortages. Japanese agronomists studying American farming statistics discovered that one U.S. farmer produced enough food to feed 27 people, whereas a typical Japanese farmer barely managed to sustain his own family. In terms of agricultural output alone, the United States had the capacity to nourish Japan's entire population indefinitely. Oil was another area where the imbalance was staggering. Japanese naval officers had long recognized that access to petroleum was a critical vulnerability, but occupation records revealed the extent of the disparity was far greater than anticipated. Japan's wartime conquest of the Dutch East Indies aimed to secure approximately 5 million tons of oil per year, a volume that the United States produced every 4 days. At its peak, Japan's oil production never exceeded 2.7 billion barrels annually, while the U.S. consistently produced 1.7 billion barrels per year, representing roughly 60% of the world's total. This meant that in terms of petroleum, the ratio between the two nations was roughly 151-1 in favor of the United States, a single figure that explains much about the outcome of the conflict. Technological differences, particularly in electronics, further reinforced American superiority. From vacuum tubes to radar systems and proximity fuses, the technological gap was decisive.
By 1945, every U.S. warship carried multiple radar systems for searching, navigation, and fire control, while even Japan's most advanced vessels typically had only one poorly functioning search radar. The proximity fuse, a sophisticated piece of ordnance, dramatically increased the lethality of anti-aircraft fire. Each shell contained a miniature radar sensor that detonated near enemy aircraft, improving effectiveness by a factor of 5 to 10. This combination of industrial scale, agricultural abundance, energy production, and advanced technology left Japanese military leaders facing a stark reality. The United States' material and technological dominance made Japan's defeat inevitable. During World War II, Japan struggled to produce even basic vacuum tubes with any consistency, while the United States excelled in mass-producing advanced technology for the battlefield. By the end of the war, America had manufactured over 22 million proximity fuses and a large number of compact radar units to be used in munitions. At the Massachusetts Institute of Technology's Radiation Laboratory, a workforce of 4,000 engineers and scientists invested $1.5 billion into developing more than 100 different radar systems. In stark contrast, by August 1943, Japan's Naval Electrical Research Department had only around 300 personnel.
The disparity in human resources extended far beyond industrial production. Pilot training statistics highlight a critical imbalance. The United States trained approximately 250,000 pilots during the conflict, compared with just 45,000 in Japan. Furthermore, the intensity and duration of pilot training in Japan declined sharply as the war progressed. In 1941, elite Japanese pilots typically logged 600 to 700 hours of flight instruction, but by 1943, Navy pilots averaged only 275 hours and Army pilots just 130 hours. By 1944, training for Navy pilots had plummeted to 40 hours, while in 1945, Army pilots received only 60 to 70 hours. Meanwhile, American pilot training steadily increased throughout the war, reaching an average of over 525 hours per trainee by 1944. In fact, the United States consumed more aviation fuel in training exercises than Japan used for its entire combat operations. The shipbuilding industry further illustrates the vast technological and organizational advantage of the United States. The 7 Richmond shipyards operated by Kaiser alone accounted for 27% of all ships commissioned by the Maritime Commission. Japanese naval engineers who toured American shipyards after the war were reportedly astonished by the scale and efficiency of production. At its peak, the Richmond yards employed 100,000 workers, surpassing the total number of shipbuilders in Japan. These 7 yards collectively launched 1,490 vessels, with Liberty ships rolling off the production line at an average rate of 1 every 42 days. Notably, the SS Robert E. Peary was constructed in a record 4 days, 15 hours, and 29 minutes, underscoring the extraordinary industrial capabilities of the U.S. war machine. First-hand accounts from Japanese military leaders during post-war interrogations provide a sobering perspective on the numerical and material gap between the two nations. Admiral Mitsumasa Yonai, who served as Japan's Navy minister during the war, remarked that while Japanese leaders were aware of the United States' overwhelming industrial strength, they had placed faith in the so-called spirit of Yamamoto to compensate. He acknowledged, "One Japanese soldier might be equal in spirit to 3 Americans, but one American factory could outproduce 50 Japanese factories." General Yoshijiro Umezu, chief of staff of the Japanese Army and a signatory of the surrender, later reflected from Sugamo prison, "We approached the war with the mindset of the previous conflict. We brought swords to a battle of factories." Economic figures reinforce the stark reality behind these testimonies. Japan's GDP at the time of the war amounted to roughly $7 billion, while the United States spent an unprecedented $341 billion on the war effort. Post-war evaluations made it clear that Japan's strategy was not just militarily challenged, but economically untenable, and that the scale of American production and resources was simply insurmountable. In 1941, Japan's total economic output amounted to roughly $7 billion. To put that in perspective, the United States poured $2 billion into the Manhattan Project alone, an amount surpassing Japan's entire government budget for 1943. The disparity in financial resources between the two nations was stark and unbridgeable. While the U.S. primarily funded its war effort through the sale of government bonds willingly purchased by its citizens, Japan resorted to printing money, triggering an inflationary surge of approximately 300%. The numbers alone foreshadowed the strategic impossibility of Japanese victory. When one examines cumulative wartime production, the contrast becomes even more striking. The United States manufactured 324,750 military aircraft compared to Japan's 76,320, establishing a ratio of over 4-to-1. Aircraft carriers tell an even harsher story. 141 for the U.S., merely 17 for Japan, an 8.3-to-1 disparity. Submarine production favored the U.S. almost 2-to-1, destroyers roughly in the same range. Merchant shipping capacity was an astounding 8.2-to-1 advantage for America. Similarly, U.S. output of essential resources like oil, steel, and aluminum dwarfed Japan's production, with ratios of 151-to-1, 14-to-1, and 7.5-to-1 respectively. These cumulative statistics painted an unambiguous picture. Japan lacked the industrial foundation to sustain prolonged conflict against America. The outcome of this imbalance extended beyond the battlefield. Japanese military officers, in post-war testimonies, acknowledged the overwhelming superiority of American industrial capacity. These officers, initially humbled by defeat, became instrumental in reconstructing Japan's peacetime economy. The insights they gained from studying U.S. production techniques laid the groundwork for Japan's remarkable post-war recovery. In 1950, W. Edwards Deming introduced modern quality control principles to Japanese industry. Executives from leading corporations attended his seminars, absorbing methods that would transform manufacturing processes nationwide. Former military leaders, now turned industrial entrepreneurs, adapted mass production techniques they had witnessed in America to create consumer goods for a recovering domestic market. By the 1960s, Japan's automobile industry had emerged as a global competitor to U.S. manufacturers. Within a decade, Japanese electronics captured international markets, and by the 1980s, Japan had achieved worldwide economic prominence, not through military conquest, but through disciplined strategic production. The accounts of Japanese officers provide one of history's most candid acknowledgments of misjudgment. They realized that modern conflict hinged less on courage or personal valor and more on industrial capability, organizational efficiency, and sheer output. The phrase 10 times the industrial capacity encapsulated the decisive factor in the Pacific War. Japan's defeat was inevitable, not because of inadequate spirit, but because of an insurmountable gap in production potential. Yet, in learning from that gap, Japan harnessed the very knowledge of its adversary to cultivate an era of peace, innovation, and shared prosperity, demonstrating that former enemies can become architects of mutual success.